All right. Stripe ships 1,000 PRs a week from AI agents. Cursor's team has 35% of their code written by autonomous agents. And Factory AI Droid just ran a coding mission for 16 days straight. The shift is actually happening. And we have autonomous agents that are actually landing here today. And I am here live at Factory HQ with my with the founding team who's been working on something really special that we're going to get into. And this whole stream is sponsored by Factory AI. And if you stay tuned towards the very end, we got some tokens for you that we're going to announce, and some links and a bunch of other stuff that you may be able to figure out how to get some of that stuff to play around with this. And sitting down with the founding team, obviously, for a deep technical discussion about missions. And they're going to tell us a little bit about what this whole thing is, what the AI agent goal, how it figures out what to do, and basically how you're, in essence, not sitting down in your seat prompting all the time, but taking advantage of these new AI tools. And we're going to go deep on how they actually work underneath the hood, like why they went multimodal with different models doing different jobs and stuff. And also the self-improving signal system, which is really interesting and unique that I'm not really seeing another system. And maybe we can see if we can talk a little bit about how this compares between like Stripe and Cursor and what these other companies are doing. And lastly, like, what does this really mean for software engineering? Because this is a live stream, this means that you can actually join in with your comments and everything. So we'll just slide you right in at the bottom, just like Direct says, let's cook. And this is going to be a really fun time that we're going to have with us. We actually have a grand screen right here as well. So we're going to be able to display your comments, and we're going to see what you guys are really cooking with live. And so, hey, looking forward to this live stream. Yes, this is going to be really awesome. So without further ado, let me just go ahead and start to introduce you guys to the team. So go ahead and introduce yourselves, guys.
Yeah, totally. Hey, everybody. My name's Eno, co-founder and CTO here at Factory.
My name's Theo. I'm a software engineer here.
And I'm Luke. I'm an engineer, also kind of leading a lot of our agent core initiatives, stuff that has to do with like our model harness.
That's awesome. Yeah. So tell us a little bit more about, for those who may not have heard of, Droid or Factory AI, what are you guys a little bit, and kind of what is it that you're working on here? And then kind of how does that lead us into this new era of, agentic software engineering that people are working on?
Yeah, totally. So for those who don't know about Factory, we basically build a platform that primarily focuses on helping organizations transform the way they build with AI. And we pair together a model agnostic agent harness that we call Droid with an agent readiness and an agent effectiveness platform that basically looks at what you're doing today with AI, where are the opportunities for you to bring more AI into your organization. And then once you've actually delivered that AI, how do you measure how effective it was? And so, today I think we're going to talk about some of the work that we're doing on basically advancing long-term goal-directed behavior of these AI systems.
That's excellent. Yeah. And so in terms of like what these things do, I talk a little bit more about like how you guys kind of stumbled into this type of thing, right? It's like, was it something that was pretty obvious as far as like, the way these agentic engineering stuff was going? Because I've seen a lot of things like Gas Town. I've seen a lot of things like these other concepts that will try to like run these things into a loop, and then outputs a bunch of stuff. And so a lot of the industry is concerned about generating slop, and how do you actually combine this together? And I was just kind of curious about your guys' insights and how do you guys start to move into this direction here. And while this is going, I'm going to try to see if we can get the screen set up for showing you what this looks like.
Yeah, totally. Maybe I can start by just introducing what missions are, and then we can talk about sort of like how that came about. Basically, Droid, the model agnostic agent harness that we build, lets you work in a bunch of different form factors. You can interact with it directly. And if you're familiar with the form factor of like Codex and Claude Code, it's a very similar where you give it tasks, it does the job, and then it comes back and can do pull requests, it can do code review. And then we had for a long time this ability to basically build, to work with Droid from a specification first approach, where you build a spec and then you take that spec and you actually execute on top of it. What Missions does is it takes that one step further and really builds out a very complex combination of features and validation criteria that lets Droid work for very long periods of time in order to create very accurate software. Software that's validated, that works properly. And there's definitely a lot of stuff in the ether of like multi-agent architectures. And maybe Theo can talk a bit about sort of how we thought through missions.
Yeah. So I guess the seed for missions was actually an Anthropic blog post. I believe it's called Effective Harnesses for Long-Running Agents, where they basically defined like a way to break down a large task and kind of use individual workers to execute them to build like something large. And yeah, we built on top of that. There's like a lot of things that we did where honestly, I don't know where I would start with it. But I think if we continue to talk, I can kind of share some of the insights and some of the problems we face and how we solve them.
Yeah, I think that's cool. Luke, if you want to kind of.
No, I was just going to chime in that, just anecdotally, I remember like Eno would be sending out a bunch of like spec generated PRs. And I remember at the time thinking like, wow, these are like getting close to the mark, but they don't quite hit. I would still have to go in, drop some comments. And then there was still, a portion of kind of like that review cycle that we needed to go through. And so part of the goal here was like, can we give it a large task, break it down for you, right? And then ensure that at each step of the way, we're doing the validation that maybe like a person would have done on a per commit basis.
Wow.
As they're kind of breaking down and working on that task.
That's massive.
Yeah, totally. And I think that one of the things that, so when I think about, that Anthropic blog post is great because it sort of was an initial attempt at task decomposition, which is, I think, one of the things that Missions does well. And basically it was like, take a task, turn it into a bunch of features, and then let agents work on those features and clear the context, which actually sort of works and basically is what Ralph Wiggums and a bunch of other folks techniques sort of base their strategies on. It's like clear context lets you work more effectively. And if you have a big problem, if you break it into a bunch of small problems, it works better. But there are so many issues that happen when you try to actually take that approach and build on top of it. Particularly, I think validation was one of the things that we found. I'd be curious I think you should walk through some of the stuff that we did on validation, because I feel like that's one of like the key areas that's just really difficult to nail.
Yeah, for sure. So basically, this initial system that proposed in the blog post had workers basically validating their own work. So the worker would take a feature, implement it, and basically be instructed to, okay, now like please, test like the user surface. But the issue is that basically there was no kind of structured, like a deterministic kind of validation. So that's I guess one of the more novel and important aspects of missions is that in the initial planning phase, we actually we define a lot of things, right? It's quite an extensive phase. But one of the things we create is a validation contract. So a validation contract is basically generated from, like, let's say you have a spec for what you want to build. We convert that into assertions, so such that like the sum of these assertions basically can define like the shape of what you want to build. And basically, if you've actually built what you desire, all these assertions should pass. And then basically per milestone, there's a concept of milestones, basically like a group of features. Basically, per milestone, we basically say, okay, after this milestone, which of these assertions should now pass? And then we basically spawn agents to verify those assertions. Mm-hmm. And yeah, I think something that we've touched on a bit, but I think something pretty significant about kind of what these assertions are is they tend to test like the user. They test from like the user's point of view. So like the surface closest to what the user is using. Because I guess the philosophy behind that is that how do like people actually find bugs in software, right?
Right.
Well, they use it, and then when they do some action, and then what results is not what they expect, then that's a bug.
I see.
Right. So I think basically by testing the user surface, you can like cover what's really important, and also it just kind of cover like all like the actual paths within the code as well in like a very efficient way. And yeah, there's more, but
Yeah. So, because I was just pulling mines up right now, because this is currently running, and basically what I'm doing, it's got like 76 stacks, and this is massive. I actually have, I think it says cached 20 million tokens, output 85K, and I'm basically shipping an app, and it's for the Canoe Club over in Hawaii. So they need a way to like get everyone on board, who's available, who's actually can do paddling, and so like this, it's like a shoot for a sport. It's got like authentication. It's got, you can sign up, you can create your own groups. It's got the whole full-fledged app. Everything, was just a conversation, trying to figure out what this looks like. And I said, I want to hook it up to Convex. I want to hook it up to Clerk. It's running its tests and so forth. So this is like the mission control for me. And hopefully you can see it. It might be a little too small for someone's eyes, but let me see if I can kind of change that. Let me know in the chat if you guys have any problems seeing this, because I would love to see if I can kind of show you anything here. So, but as of now, we have like the active feature that's currently going here. So we hit F for features. This will show us all the features that it's been working on and how it's like organized everything. So there's like 76 of them, and you can see all the stuff that's completed and how it's organized them here, right? And then we can we hit escape to go back, and then let's see if I can go back here. So let's see here. Whoops. I'm doing this through a remote machine because it's like my Mac Mini at home. So I think
tab as well.
Oh, hit tab. Yeah, I think my Mac Mini is. It's kind of like really slow to respond, probably because of my connection and so forth. Because I think I'm probably doing a really high speed connection, thinking it's like a LAN network. So I might try to see if I can connect. But yeah, I'm gonna see if I can kind of get that reconnected. But for now, we're just showing you like you guys are shipping like all kinds of things, right? Like this thing is not also meant for 021, but it's also meant to go in your code base. Can you guys talk a little bit more about that? Because I think that a lot of people are really curious. So it's like, oh, cool. Like, yeah, I can make a app from scratch. Like, but I'm not that. I work at a company and we have an existing code base. Would love to hear more about your experience with that and kind of the thinking through of what's actually happening underneath the hood. Yeah.
Like distill into the system is best engineering practices that we abide by, right? So when we think about implementing a feature, we think about it both from a validation perspective of like how would an agent actually go about and validate this later on, but also how do we make sure that like, you have the proper LINT rules and proper like testing, unit testing that is in place, maybe even end-to-end testing, such that as you're working on a mission, right, a project with like potentially like unbounded scope, you can continue to have like those same software development like guarantees in place. So like if you make if this feature causes a bug somewhere else in the product that you're creating, you end up getting feedback via that end-to-end test, that unit test that maybe fails. In addition to that actual validation that we're performing from that like user testing perspective. And I think that really kind of goes to drive these outcomes that can be 0 to 1 applications. So we could tell a mission go ahead and create a Slack clone, which was one of our like original ideas as we were building this out. And then nowadays I've been using it to like perform huge refactors of our code base, right? Situations where we have end-to-end tests, we have unit tests, and then now we're trying to see, okay, can we couple both the user testing and these like sort of like deterministic tests that we have in place to reach outcomes that are like, well, I would have thought about 3 or 4 months ago were previously like unattainable.
Yeah, and to add on about kind of test-driven development, because we mentioned that, yeah, like one of the things that the workers do is whenever possible, they'll write like tests first and then implement. And kind of what this does is it causes like if the worker like implements first and then writes tests, right? Its tests that it writes will be influenced, like biased by the implementation, which will make them less effective at actually catching like bugs. So we apply that at the per worker level. That's one of kind of the best practices Luke said that we kind of enforce. But I think, the validation that I talked about earlier, right? Where we kind of during the planning phase will like come up with like a list of criteria or assertions that need to pass. And we do that before we even like make the feature breakdown. We certainly do that before any implementation happens. And you kind of see it as like a higher order kind of application of test-driven development. where again, you're like defining these criteria based on purely on like the spec that the user what the user expects, rather than being influenced by what actually exists.
I see. How different is this from, like, I hear other people saying, well, I don't write plans anymore. And so maybe explain a little bit more about what a plan and spec is, in vocabulary terms, and then how you guys view this type of engineering. Cause I feel like you guys are totally on a different like level. And I don't think people realize like what's really happening underneath the hood to make this system be really intelligent. I would also say efficient in some ways because you're actually using different models too underneath the hood for one thing and the other, and also how you're kind of thinking about the context windows and how everything is playing here. Is it just like one session? Are you just swapping the model out, or are you actually doing, what's the concept of sub agents? Because people, I mean, I guess personally speaking, I have, try to like launch these parallel agents doing all this crazy stuff. And I don't know, raise your hand if you've ever had the same thing too with you out there where you're just like, yeah, I have like 50, Cloud Code windows open. I have like a Codex window over here, and then I have them arguing, and then I have, all these crazy things going on. I guess maybe what I'm trying to ask is like, take me through a little bit of your thinking of, now that let me zoom out. You guys are obviously cooking something that's working. You're scoring the top terminal bench scores and stuff. There is a reason behind that. What's kind of like the sauce there, and what's the thinking for even specs? Like how does that go into specs and what you guys are actually doing? Yeah.
Is right. Tools like Cloud Code have like a planning mode. We like to think of planning or specs, or I guess specs as slightly different than planning, right? Planning is how will you implement this feature. Specs, which is what Droid does, are how will you implement this feature and validate that it's working, right? And so you as a human are in the loop deciding both of those things, how it's implemented and then how it's validated. And then as you move on to kind of high order thinking, what we're trying to achieve with missions, right? It's like, how can we get the human a little bit removed from that process? How can we define the task that you want and reliably achieve the sort of like those checkpoints, those like targets that are part of like ensuring that this feature is validated and implemented correctly, right? Deciding that automatically for the user, but having them yet still have a way of like managing and understanding where they're at in the mission lifecycle.
I'd say also that like in missions in particular, I think like a big point that's important is that the initial planning phase should basically think through everything. That's how we can maintain coherence across this really long horizon, is that initially like the models, like especially the newest generation models, are at the point they're at the point where they are actually able to like plan out really large projects. Like even if you have a really huge spec, it's still like very compressed down compared to like the code that's required to implement it. And yeah, also there's like, they're also very good at delegation. So like another like important principle behind missions, I think, is like separation of concerns. Like your orchestrator, for example, like for any investigation, anything that requires kind of like looking at things more granularly, like investigation, it always delegates that to sub-agent. And it doesn't implement anything, right? After the features are defined and it starts running, if something's surfaced, like there's some kind of blocker or some issue that requires like re-steering, redirection, it just purely does like, it redirects by editing like this features file that basically determines what workers will do. Yeah, so I think it's the reason that missions can run so long and maintain coherence is because of how much compute really goes into the initial planning phase.
Yeah, and I think that one of the things to understand about sort of, I always think that it's helpful to understand why did we build such a system. And when you think about what customers are able to do, maybe a little bit of outside noise, we see a broad diversity of customers. Most of them are in the Fortune 500, but there's startups, scale ups, solo developers, and generally people who are quite advanced with using AI have figured out these like really elaborate ways to spec out and scale out the usage of agents. But I think that when you think about a problem that a like systemically important bank has, we have this huge legacy code base. It's actually 2.5 million lines of code. If it goes down for a second, like a state will be unable to do their taxes for the week. And for them, it's just simply not an option to sort of like look at a markdown spec and then say, hopefully this works. Even if they validate the code, it basically actually doesn't offload any of the time savings. Like you still basically have to go through the exact same process. But when you are able to upgrade the rigor by which the sort of specification and validation criteria are created, and you're able to actually vet and look through every dimension of, when we say it's going to migrate this table, what does that actually mean? What does correctness mean? Then people are able to spend much more upfront time reading through that basically high level specification and validation. And thus, if you actually say, we want an AI system to fully modernize this entire code base, the end result is just more trustworthy. And that time savings of being able to point out, no, we actually know exactly what validates that this is correct, and provide that to a large business, and also do it in a way such that they don't have to be sort of like perusing the internet for esoteric ways to manage agents, and instead are given like a clear interface that says you interact with an agent until you and the agent are both fully in agreement about what should be built. You understand exactly what good means, and then you can send it off and let it do work. This is something that we feel is, with Missions, it's now here, but up until this point, it's sort of like missing from large enterprise conversations. And it just so happens that this thing's also pretty insane at making like 0-to-1 applications, working in greenfield code bases, doing all this other fun stuff. People are using it for research, for particle beam like management. There's all these crazy, there's a bunch of use cases that have been super interesting to hear people use, but
that's insane. Solving math problems probably, and next coming up.
There's been some, one of the first things we tested was trying to train basically a protein folding model that achieved like near state of the art results on like the popular protein folding data sets that like DeepMind had. And so it generalizes to a number of different fields like math, science, engineering. I think that validation basically criteria, anything that is validatable falls under it.
Interesting. I like this idea of like validatable type of things, because I just was able to get my instance back up here as we see it going. So for those who are wondering, we're basically looking at the new missions from Factory AI, and they actually have sponsored this whole stream, because that's why I'm here to talk about this and learn a little bit more, because to me, I feel like taking a peek ahead into the future of where this technology is going. And more than ever, I think these, like you guys were saying, that the agents are actually going to need you as a human to define what that is. And it sounds like to me, like the validation parts are also the very important pieces of this whole thing too. And I think back to that example of somebody was taking Next.js as a project and they were trying to make it, like a Vite spinoff or something like that. Like all of those tests that they've developed over 10 years are super valuable in those types of things. And if you can sort of work through your idea here and understand what you need to validate, or maybe the agent's kind of helping you with that process, that can help you define, what you need to lay out in your app, right? Because there's this process when you go through the onboarding here with Missions. And for those who are wondering, yes, we will have some information on like getting you some tokens and stuff, because we have an event that's going to be kicking off next week for you actually to try here in person. And so we're going to invite you here to the Factory AI headquarters, and we're going to have some information about how you can get some tokens. I think you guys are going to give away 200 million tokens, right?
Yeah, a lot of tokens. A lot of tokens for if you come swing by.
Yo, this is going to be crazy. So yeah, make sure you stay tuned in, because this is going to be really crazy. So we'll have some information. There's going to be some stuff in the description if you're watching on YouTube. And this is a live stream, so we can ask some questions. And there's some other folks who had some questions. And I want to see, there's this one here that was really interesting that says, if I might ask, now coding agent completes 80% of the task, but 20% need to fix it by hand. I can't see the agent long running, non-incremental. If anyone wants to answer this one, would be really interesting. So when I let an agent long running, non-incremental development, the rest 20% will expand. Well, how will you solve it? Yeah.
I'd say that like basically in order to even build like a long running system like Missions, like we kind of have to close that gap. So it's like individual like tasks, the individual features are not going to be completed at 80%, right? It's like the point of validation, the point of all the structure and the breakdown we provide is to get much closer to 100%. And then really, I feel like the gaps in Missions generally tend to be not like from individual features being completed incorrectly or incompletely, but rather there are like missing features. So you can imagine like it's kind of a different type of problem. Honestly, it's more manageable because it's not broken. It just is missing stuff. I feel like a lot of the time, when people say like, oh, like my coding agent does 80%, 20%, it's because it's broken, right? And they have to fix something.
Or they didn't think about the full feature and how that plays with what the user's intent is, or maybe separating, oh, this is an admin function versus, like controls, right? Like who should be touching what data or something, or that type of conversation. I mean, there's a lot of different things, right? Yeah.
Of time, like a lot of time when you go through like a code review process, which you typically are doing with agents nowadays, like you're looking at code and you're saying, okay, maybe this is a bug, right? This is something that doesn't conform to my style. This is a preference that I have over code, and this is something else, right? So the bug is the issue, right? It doesn't conform to my style. That can be encoded in some sort of like lint or something like that. And then I think one thing that we now need to sort of like release is a lot of that like control over my little preferences in the code, right? I think as agents start to write more and more of the code, something that I've noticed myself as I use Missions is I might have these preferences that are not even like lint encodable, but like I sort of need to like just take a step back and realize if I've reached the outcome that I want, maybe like that is a feature being shipped, that's like some performance requirements being met, that is some memory usage that I want to kind of cap at, then my feature is implemented, right? That becomes the new definition of like 100%. And maybe those little tweaks that you would have made 6 months ago are not really as valid from just like a software development perspective.
Yeah, and I think one of the craziest parts about Missions is that they leave your code base in a very meaningfully better state than when you started. And I think that this is something that a lot of people have been talking about with vibe coding, is like, what is like the tech debt that you incur from sort of saying, go and do this? A lot of people have this vision of like a house of cards where, you vibe code here, and then it all sort of topples at some point. But I think that what we've actually seen with Missions is that because it is so driven to write tests and write validation, oftentimes it is much better at doing that than we are as humans. And so you end up with these code bases that are filled with end-to-end tests and unit tests and validation and lint rules and all these other things that the agents are actually building up so that it can succeed on the like n+1 task. And our sort of view is that why Missions are valuable not only in these like large enterprise environments, but also for, as far as like solo developers, is because we think a good agent will sort of harness its own code base for itself.
Wow.
And basically that's what Missions do.
And so tell me also a little bit more about like this agent readiness thing that you guys have, because that's the feature outside of Missions, right? But it's something you guys have to see if the code base is agent ready. So if you're trying to adopt this into like a very large code base, should they run this first? Or is this something that Missions already kicks off? Or how does that look like? Yeah, like if you're trying to figure out like, I want to ship a feature with this, how should I do it,
Yeah, totally. I mean, I think that a lot of what you brought in, I mean, I'm curious how much of agent readiness sort of is explicitly encoded, because I think that at a high level, for folks who don't know, agent readiness is basically our framework for thinking through how to make agents successful inside of a code base. And so we look at these like 8 pillars, everything from like build quality, linting, testing, style, validation, logging, and we can actually build out sort of this thing that says, look, there's like 80 plus signals that an agent could be using to write better code for you. Let's map that out, figure out what you do or don't have. And then when you have all of those signals, agents are going to perform really, really well. And I guess you encoded a lot of that sort of very naturally. The agent readiness signals map to like engineering best practices, basically. It's just a way of encoding that in data.
Yeah, I'd say like definitely like when you enforce certain types of structure, like, this is a lot of what like agent readiness evaluates. It tends to produce like higher quality output that's more scalable and more extensible. So definitely like in missions, like when we do encode a lot of these best practices in. So if you're building something 0 to 1 with missions, like it's absolutely like not slop. Like it's really quite high quality, and like as far as we have tested, oftentimes it's like indefinitely like extensible. But if you're running a mission in an existing code base, where let's say you don't have these like things set up, let's say one example is like, let's say like your builds, for example, or something, your tests are just really slow, right? Well, every time the mission, like every worker, like because we enforce these practices, like, oh, you should always run like validators, you should run tests. Like basically, if your existing code base is really slow to test, really slow to build, that's going to make your mission slow, right? So I think like to some extent, like the mission can also kind of inject these kind of best practices into your code base. But yeah, I mean, if it has to do all of that, it's kind of a big detour off of like and it's just much less effective than having it set up correctly in the first place.
Yeah, maybe for those who are just tuning into the live stream right now, maybe let's kind of zoom back out a little bit and kind of go high level and see if I can kind of pull up a slide or something here to kind of show some folks. So like, what is a mission and kind of what is it that you guys have architected here? Because I understand that you kind of started to hack around at this like a couple of months ago, right? As a kind of like a solo project. So I want to kind of hear you a little bit, kind of like, like at a high level, like what is it? And then kind of why does it exist? Does it, and what was, I know you said you were inspired by the Claude Code thing. Maybe speak a little bit about that for the folks who are just joining in right now on the stream. Yeah.
Right. So I guess to kind of repeat the bit about the Anthropic blog post, right? They made this blog post like I think maybe November of last year, like towards the end of last year, about basically a task decomposition system, like a harness to basically accomplish, like to build a large piece of software, where you take like a task, you break it down into features, and then you have workers kind of execute the features in sequence. And we saw that and basically like thought, okay, like let's take this and see where we can take it, right? See where we can go with it. So yeah, it was like kind of last December, like around Christmas, a little before Christmas, that started experimenting with this. And I remember the first like real success was maybe like a month, like 3 weeks, 4 weeks in, where I was able to run like a mission that was able to build like a very like compelling like clone of Slack that is like full real time, everything pretty like the core functionality, like all working. But that mission was like broken down like a lot. It took a really, really long time. And at the time, I believe I used like GPT 5.2 as the orchestrator as well as the validator, and like Opus 4.5 as like the implementation worker. I think prior to that, like I tried using like Opus a lot, like Opus orchestration, Opus validation, but at the time it was 4.5. There was no 4.6, and it was clearly just not fit. Like it didn't really work. The validation, like it wasn't like very thorough. I feel like Opus doesn't, especially 4.5, doesn't care as much about correctness.
Wow.
So it might like take more shortcuts. So it wouldn't like validate properly. And even if it did, right, and then you have like validation like issues like coming back to the orchestrator, but then Opus 4.5 orchestrator would maybe just skip them or ignore them. And it was really when I switched to like 5.2 that I started seeing success. And I think that was the moment where like it was, I felt that like this is really possible.
Wow.
And then just happened like the new generation of like 4.6 came out, right? Like a little bit after that. And 4.6 is a really, really good orchestrator.
Opus 4.6.
Opus 4.6. Yeah.
But it's interesting that, we've created various validation systems, right? There's the concept of like a user testing validator, right? And then there's also another validator that we have that I'm forgetting the other name of it was
Scrutiny.
the scrutiny validator, and both of them behave optimally with a different model, right? Even nowadays, Codex 5.3, now we're going to test out 5.4, perform really, really well there. And so I think that in some ways reinforces our conviction that like having multiple models,
Yes.
even maybe different model providers in one system is actually the best way to build software with AI, right? You can kind of capture like the personality or the ethos of one model and do things that it's really good at in one part of your system, and then devote other models to succeed at the tasks that they're equipped to take on and work through.
Yeah. I think what we've found definitely is that like the nature of like different models are just different. They have their strengths and their weaknesses. Even for implementation, I believe like for full stack, like Opus is really good. For like stuff that's more novel, I think, Codex might be better. And I think it's just like the spikiness and all these different dimensions really means that you don't know, like as soon as a new model comes out, it might become the best in like, these dimensions.
Yeah.
And, that's kind of, it's, yeah.
So when the agent is doing work, you can identify gaps in thinking here, because I saw this here. There's this continuous learning. It says you start a new task, you execute, looks like you observe here, learn, and code a skill, then you come back to the new task. Is that part of the, like, as this thing is actually going through the mission, whether it's an existing code base or whether it's generating a new feature for that specific, milestone, is that what it's doing actually in real time, kind of just generating new skills? And does the skill have to be optimized for the Opus model, or like, how are you guys thinking about this? And like, how does that round tripping work? Yeah.
Yeah. So like in the beginning of the mission, like we already we create skills based off our initial investigation of the code base, basically like your best practices and just anything that's really important for all the workers to follow. And yes, like so Luke mentioned the scrutiny step. So like right now during like milestone validation, there are two validators. The first one is scrutiny. The second one's the user testing that we've already spoken quite a bit about. The first one is scrutiny. And scrutiny basically does two things. The first one is a code review. I mean, I think, if people who are like power users of like coding agents would know that like if you have one agent kind of implement and you tell it to like check its own work, it's going to be biased and not do a thorough review. But if you tell like you have one agent implementing and a fresh context window to basically go through and validate and like code review, it's going to be more effective and catch more things. So first, like scrutiny has a code review step, and then it has like a procedure review step. And that procedure review is kind of where we're able to learn and kind of optimize for future workers. I think an interesting thing about like the learning aspect though is that you really want to be careful about what you actually encode. Like the thing about like coding agents, like these like frontier models, is that they're actually very good in general at just kind of getting their bearings, right? That's why people can use like stock coding agents to be effective, because they're very good at like gathering that initial context and kind of getting situated and finding stuff that it needs to implement something, especially if your task is like well scoped and like reasonably scoped and well specified. So like we really only want to learn things that have been proven, like say like multiple workers, right? Both all ran into the same type of issue. Well, that's a signal that, we should probably save that time for future workers and encode it. Or just things that like are obviously like should be added to like shared state. But yeah, for sure, like I think it's kind of a failure mode where you kind of try to stuff your agent's context with too much stuff that you think is going to help. But really kind of, it's just distracting. It's like a lot of the time it's not useful is what we found.
I see. So can you share some of the secret sauce? Because somebody was asking here in the chat about some architectures. Can you recommend like the practice for letting the agent design like architecture and POC to find, let's actually put this in the chat. So here you go. Cool. Can you recommend any practice to let the agent design architecture and POC to find constraints, limit costs, because the agent design and scope, not thinking the future usage? I think it's just about, I'm also curious on top of this is more of like go ahead. Yeah.
Yeah. So I think I'm going to interpret the question here to be basically like how did we actually evaluate this agent architecture and like how they communicate properly? And I think that there's a bunch of different like primitives, it feels like right now in agent communication. Like there's like a delegation primitive. We have sub agents where agent says, go do this thing. There's like creator verifier, which I think we just described of like one agent creates, the other verifies. You have like inter-agent communication, DMs or like sort of like messaging between them. Orchestration with parallelization is another common one. And like broadcast style communication where maybe there's like some centralized communication strategy like a forum or like Slack. And I know that you had a lot of thoughts about like parallelization and inter-agent communication. This is like, I think all three of us basically came in with completely different priors on, and many others who worked on this. Like, I think honestly, it was like a constant debate about like, and it's still actually open question of like what the right strategy is for parallelization. And I'll talk about evals, but I'm curious like if you have any thoughts on that.
Yeah. I mean, I can speak a bit on parallelization, I think, like I know like there's like a lot of blog posts published by like Cursor or Anthropic, and Anthropic also had that like Claude Code Swarms teams thing that where they're all like parallel approaches where you have like a bunch of like workers spawn at the same time to do different things. But yeah, I guess my philosophy with parallelization and the reason that Missions kind of parallelizes very sparingly and like specifically, like in validation, we can parallelize, right? During exploration, initial like planning exploration, we can parallelize like the investigation. But basically like Missions, like you use Missions to like work on systems, right? You use them to build systems. And like when you're making a change to or like building a system, you can plan everything out in advance. Like you can really figure out the entire plan, like define like, everything that needs to change, right? Everything you need to validate to ensure that it's changed. And you can define everything up front. And like, because of that, honestly, in Missions, like there isn't like, it's serial and there isn't actually much, like we only communicate between agents as necessary, really. I think where parallelization can be more useful is if you're working in like a dynamic environment and you kind of need like more heads to basically like gather like live information. You need to react to it. But yeah, I guess the idea is like with Missions, right? I believe parallelization just makes like it harder. And if you haven't even solved the question like how do you produce something large and correct, then it doesn't make sense to like add parallelization into the mix there.
Yeah, and there's actually great research that Google did that came out in the middle that actually helped solve this like very concretely and empirically. What it did is it looked at a bunch of different strategies of agent communication and parallelization being one of them, the swarm strategy being like very concretely outlined. And what it found is that exactly what Theo just said, like validation and search and exploration are both great use cases of parallelization. So in Missions, we parallelize when that happens. It's like it'll dispatch sub agents. They can search on different parts of the code base. They can validate in parallel. But when you're actually working on code, people often think like, oh, well, if I'm on the front end and I'm coding and I'm on the back end and I'm coding, those can happen at the same time because it won't conflict. But just the negotiation that needs to happen between agents to figure out who's going to do what is actually enough overhead such that the serial approach finishes the problem first. And so it's just better to execute serially and parallelize only sort of in these areas. And I think that there are plenty of ways in which a more elaborate system, like maybe parallelizing on different machines and comparing the results, could potentially actually be even better than what we have. But it also requires like stuff that I like infrastructure, and you start to really add layers of complexity that are much harder to evaluate.
Just to add on one more thing.
Okay, go ahead.
Right now, okay.
You're good.
Yeah, to add one more thing on is I think right now, like the way that sub agents are designed from the model lab perspective, they're not equipped to take on this large of a problem and decompose it correctly, right? And so that's why we approach this from the perspective that we did. But we have to stay like super reactive here, right? So I think there's entirely a world where maybe a year from now, 6 months from now, who knows, the model, like the behavior that we've sort of like encoded deterministically can sort of make its way into models, and then we can react. But we've structured the system in such a way that like making those reactive changes is super easy to do, right? It's like, you know, 1 day worth of effort. And I think that's going to benefit us a lot as we kind of build the other layers of complexity that Eno was mentioning.
And somebody was talking about saving tokens because, you know, I think there's like a lot of steps that is going on here. And, you know, it's probably pretty easy if you have like infinite budget to just kind of burn through everything and just say, okay, Opus fast it all, you know, and it gets you to think about things. But if you have maybe Opus for your main like brain of things and you have local models, they should be able to hook it up to your harness, right? Like your harness can run, you know, you can run a GLM5 or something if you have the setup to do that on your local machine to do those small tasks. And your verifier can be either a GPT model or something else that you want to be, right? And so that feedback loop, maybe 90 or 80% of your token usage could probably just be local. And then you just have a orchestrator brain that's, you know, like some lab somewhere, right? That you just pay for. And so now you're paying for like an intelligent brain who's going to orchestrate everything. And then now in this mission that you're running, you know, you could probably do a lot of stuff locally. I don't know. Have you guys experimented with that at all?
Okay. Yeah, totally. No, that's like why we love like the model agnostic approach. And I think that it gets at a broader philosophy. It's like when you think about what we are trying to sell you, tokens are an intermediary. Like we don't actually want to sell you tokens. We want to give you outcomes. So we're trying to say, what is the fastest route for us to solve this problem for you? And if we have a harness that solves this problem for you really well and in a cost-effective way, that's what we want to give you. But the model labs are selling you tokens. That's like they don't care about any of the other things. They only care about how many inferences are you doing on our models. And I think that what that means is that over time, as we've started to discover some of these use cases, it makes an even stronger argument for being model agnostic at the harness layer, because you can say, look, we can actually approximate like 90% of the quality of a full Opus run by just using Opus as the brain and then executing with like GLM or like GLM5 is great, Minimax 2.5. And there's a bunch of these models that have come out that are very, very close. And when you run them on an eval, you're evaling just that model. But when you run them in our harness, you're getting like probably 90% of the upfront benefit of the intelligence of like Opus. And then the execution is almost like mechanical.
Wow.
And so I think a lot of our customers also appreciate that, you know, if in 2 years, one of the model labs just decide to ramp up prices, there's like an option, right?
Whoa.
And that's us.
That's wild. And so how did you guys get so passionate about this? Because I feel like, you know, it's so hard to find different people and maybe explain a little bit of your backgrounds, because I don't think everyone really knows where you guys come from and maybe what you worked on, Luke, and then kind of on through to each of you guys. Yeah.
One other thing I just wanted to point out about like token usage is I think missions can be somewhat misleading in that, like, you know, you're running them for, I don't know, 17 hours, 2 days, whatever it be, right? The actual amount of time that you're spending like on inference is actually like quite small, given that you're doing a lot of like tool executions that probably take some time, right? A lot of those end-to-end tests probably take quite a while to run. So I think that's just something that I wanted to point out as like something that, you know, for folks listening in. And then in terms of my background, before I was at Factory, I was working at Block. I was one of the founding engineers on the Goose team. And so that, I think that and my background in like developer tooling really just like made me fall in love with agents from like a software engineering perspective. You know, what sort of like wins can we achieve in the software development lifecycle using these like really, really potent tools, right? And so that's what brought me to Factory in the first place. And then the rest is history. I think I've had, you know, an amazing time building here.
Correct. So we have those folks here, ladies and gentlemen. And so start queuing up some questions that you have for this team. Have you played around with missions yet? Have you been launching anything yet? Have you run into any issues? What are you seeing? I think somebody asked about tokens and generations and like that. We also have something coming up towards the end of the stream. We're going to tell you a little bit about the event that's coming up, and also 200 million tokens that are going to be coming down the pipeline that you can get to try out this stuff. So this is sponsored by Factory AI, and I'm here trying to learn more about this because this is going to lead into us trying to figure out what is this thing? How does it work in my repo? And there's so many different questions. So yeah, make sure you stay tuned, start queuing up some of those questions, and we're going to take a look at it. But yeah,
before starting Factory, I was at Hugging Face working on open source model development, helping sort of like larger enterprises make use of, at the time it was like language models. The extra L basically was sort of forming while I was there. But my background is really I've been interested in like cognition, in neuroscience, fMRI, EEG, deep learning strategies, and that sort of brought me into like the transformers world, and ultimately informs a lot of how I feel like I think about LLM based systems.
That's amazing.
Yeah, I guess the start of my like LLM journey was really around when GPT-4 came out. And it was really fascinating. I remember I read the paper where they were exploring like all the different like capabilities of it. And yeah, like I initially built like a chatbot. That was my first thing way back when. I joined Factory pretty early. I mean, at Factory, I've worked on, I think, a lot of like I've done a lot of prompting work, I think, both in like our product, in like our core agent loop as now Missions, but also in just like my work. And I think that's like an interesting point. It's like, I feel like what you really need to like build a good harness for coding is like really good intuitions around how to get coding agents to go on specific trajectories, right? Like how do you build the context to get it to complete your task, right?
Yeah.
Like if you're like lazy like me, right? I want the coding agent to do all my work, and it needs to be correct.
Facts.
So you're kind of forced to develop intuitions around how to prompt, and then those are like valuable if you're trying to like chain these together and build them. Like it's kind of the same intuitions. Yeah.
Whoa. So then tell me, how did you feel like? I mean, the product feels like it was done by 300 Microsoft employees. It's like, when people think about scope of work, there's massive attention to detail and like so many things that can go wrong, especially in prompting. How did you figure out that you can, so you talked about earlier about like making a Slack clone, but you were impressed about the level of detail it was able to do. What made you want to keep pooling and just kind of keep basically going and going and going? Did you ever see that there was going to be a light at the end? Or did you run into any roadblocks and say, I'm about to give up, it's a month in, for working on this project?
I'd say like the light was when that Slack clone worked. It's like once it works and once it can produce that, like even if I had to do a bit of steering on that run, like it's clear that it's possible. And then from that point on, it's just kind of optimizing. One thing we honestly had to optimize a lot for was UX. Like the initial version of like Missions was really like painfully slow. That was like the feedback that we got a lot. And yeah.
Yeah. Oh, cool. Yeah, I was also curious about, I mean, it's just really amazing to just be here with you guys because this is a product. I think you had mentioned that you worked here early on. One of the most impressive things that I was able to do from the very beginning is like run, 12 million tokens in one session, like not have to create a new chat. And like that fluidness was like, it felt like a big stress relief for me. It's like, finally, I could just keep going. I have the feature. I want to see it all the way to the end. I'm testing it myself. I'm just, in my seat though, I'm prompting away and I'm thinking, okay, cool. This is the future of coding. It's just me and my desk, yelling at this thing. But I can keep at least one window going forever. And at that time, I'd have to open up like tons of Codex windows, tons of Claude Code windows, tons of like cursor windows just to, 60,000 tokens on my context. Now I got to open up this thing and hand it off and like keep handing off. And it was like, okay, where did I go back and fix that bug that caused a regression again? And then like, I was just managing too much things at once. And I think that's probably a breakthrough that I think I saw with Droid and it was really impressive to me. And I was like, hey, I got to tell the world about this. This is really, really cool. And you worked on that, right? Like how you can have a long session. Tell me a little bit more about that secret sauce. If you have a blog post about this, if anyone wants to check it out, I think it's called something about compression or something. What's
Yeah, it's called compressing context.
yeah.
Yeah, I think like the concept behind like context compaction in general is that you just need to like retain the things that you don't need to retain everything. You need to retain the things that the agent needs to kind of get back on track. So it's just like depending on what domain you're doing, like in coding, right? There are certain things that are obviously important, like file paths that you edited, right? I mean, if you're like an interactive kind of coding agent session, also stuff like all the user messages, everything the user said is also very important. It's really just a matter of kind of preserving all those things. And like we have like an incremental approach that honestly like Luke also, we all worked on, where basically to avoid overwhelming the LLM, like we kind of iteratively, like whenever we need to compact, we take like that new section that we need to remove, we kind of integrate it into our compaction artifact. But yeah, that was fun. That was one of the first like kind of really interesting like prompt based features that I worked on that made me realize like like as a software engineer, right, you do have intuitions around how you can get agents to do things that like researchers might not have.
I see.
And
Because as an engineer, you got to ship and you got to get that feedback as fast as possible.
yeah,
Where in the research space, it's at like a very different scenario. There's different pressures and it leads to different ways of using the models too. I think that's another thing that's interesting. And so I think there's also a couple different concepts that people are talking about. It's like, as Claude Code team talked about just agentic engineering, other teams like Stripe also spinning up their stuff. And, this concept of people in their in their actual organization using the tool shed. These engineers are now making the tools that are going to give the agents access to it later on, because maybe they know that piece of the code base. How are you guys, like in your conversations with these other companies, or how are they thinking about this new, I guess, realm of agentic coding that we're moving into now? And there's also other camps that say we don't trust it yet. Has the feedback been like everything's good, we don't like it, or like what's kind of the vibe? Yeah.
Yeah, I think that we've seen. So what's cool about Missions is that it seems like it's probably our most ambitious. Like it's basically saying, please hand over control for 48 hours straight to an AI system to do what is clearly the work of probably like 3 to 8 humans over the course of like a week or two. And so surprisingly, that has actually convinced more people who were skeptical that this is something worth investing in than I think a lot of other features we've shipped. And maybe it's just the quality, maybe it's the fact that it actually works, and sort of people are seeing a glimpse of what is possible in the near term. But I think that a lot of businesses are coming to us because they actually do have the sense of, hey, I know something is coming. I know that the world is transforming. I don't exactly know because I've adopted like I gave everybody Claude Code and the world hasn't changed yet. So like what comes next? And I think that what we're able to offer is sort of not just like what you see with Droid is sort of like a surface of our platform. And I think more broadly, what we try to do is when we work with a business, we say, why do we even have agent readiness? It's to be able to say things like, okay, you're right, the world hasn't transformed, but look, like your code bases basically can't even take advantage of these agents. But look, like you're not even automating things like code review and incident response and documentation. But look, you haven't even begun to explore what a large scale orchestration of agents could look like, what background agents could be and sort of once you have all of those things, how do you like hill climb? How do you move to the next step? I've been sort of joking about this recently, but like Disney, like when Walt Disney created Epcot, what he was literally trying to do was basically build this like little mini city and say like, this is what I think the city of the future looks like. And so I think in many ways, like what we do internal to factory kind of looks like Epcot. It's like there's like, flying cars and all this crazy stuff happening internally where we're trying to say, this is what the future of software development looks like. And when people see that, they're sort of like, oh, okay, well, we do not look like that. How are we ever going to get there? And then we give them the roadmap of how they're going to get there.
Wow, that's really, really cool. And if you want to start playing with this thing, there is a Luma link in the YouTube description right now. Go and sign up because you can start playing with this today. I think, you just said like minutes before the stream that you guys also turned on missions. So
So we
that
YOLO flipped a feature flag for this. So it's on now.
So if you're on any plan, you can get started, and mindful. It's going to chew up a lot of tokens, right? Like if you're running this thing for the first time, it's going to do planning and do a lot of stuff. And so, uh, I want you guys to play with this as part of the Factory AI team sponsoring us. Like, I want people to really, go crazy with this. And so they're actually like literally going to the bank, dropping a bunch of tokens into like the dump trunk. And so next week, you're going to be able to, if you sign up for the Luma event, if you come on site, you're going to get 200 million free tokens, basically a month's worth of tokens. And we're working on something for the folks live because I'm going to be doing a live stream here as well at Factory. And if you're trying to figure out how is this going to my business or how I should be using this, you can actually come here on site and talk to the engineers, talk to these guys, talk to anyone here, talk to other people who are building. And we're here in San Francisco right now. So the Luma link is live. Go ahead and sign up. Put your name on the list, and then they're going to start activating the accounts. I think probably by Tuesday they'll turn on they'll send a bunch of notices for you to get your $200 $200 voucher. You're going to get a pro plan basically, 200 million tokens to go play around and start launching a bunch of missions. And then we're going to have some prizes. I'm trying to see if I can secure some Mac Minis because they're all sold out right now. And some other cool prizes to see like who can build something really interesting, who can share some really good tooling or whatever the stuff that they're doing. So stay tuned for more. We're going to have some more information for you on that because this is part of why I love the Factory team is that they're so cool to like not only just be on the cutting edge thinking about this stuff, but it's just a small handful of people here in the office, that are making this stuff. You would think that there's these massive amount of teams that are shipping this quality stuff. And I don't know, talk a little bit more about your workflow too, about how you are using your own products to verify your own things and have some confidence. I know that other teams like, Stripe, I know Claude and these like Cursor teams and stuff are using that as well. And maybe what are some of the differences in your product that you've seen so far compared to the others? While I take a quick bathroom break. So yeah.
Speak to is a little bit about like our code review process internally. Like I think Droid, when we started off building it, we definitely noticed that like the bottleneck soon became the code review process, right? And so we built out a /review command. After that, we built out a revised approach to how you do code review in CI. And so we leverage those extensively internally. But I think what we're now realizing is like the agents are getting so good that we can automate more portions of the tedious aspects of software engineering, right? Stuff like you got a bug in production that happened today and you now need to triage it, need to create a new like linear ticket. You now need to prioritize that in terms of just like who's going to take that on, when is that going to happen? And that all leads to like slowness in your organization. It leads to just like inefficiencies in your software development lifecycle process. So as we think about like what's next, we've already been experimenting a bunch internally with like systems that let us essentially like hill climb on this problem. So, automations that we'll soon be shipping out to everyone who's using Factory that let you encode essentially things that you want to have happen at a regular cadence and then be able to run those. So that could be, fixing all of the new bugs in production and creating a PR that does that. Or it could be going through and looking at all of the PRs that you have open right now and addressing any comments on them or looking through CI and seeing what are the failures, right? Did lint fail? Why didn't we actually like fix that in the first place? And, maybe the agent's MD is not correct. That's something that you can learn from this new system, but you could also just have it go and fix the lint issue, in the first place. So I think there's a lot there that we'll be sharing out in the coming weeks, but stuff to stay very excited about.
Yeah, totally. We've been talking a lot about there's a popular phrase going around of like the dark factory, which is funny because I think that 3 years ago when we started Factory, it's basically like exactly why we call ourselves this. So it's like, and I think that the notion that what percentage of your software team today works directly on the software versus works on the system that builds your software? Today, most companies have probably like 95% of their engineers like directly changing software, even if they are delegating an agent to directly change their software. Like if I say to Droid, make that button round, in this case, I'm sort of saying like, no, you are directly changing that button to be round, right? And then you have at companies this like other smaller percentage. Typically, you'll call them like dev platform or dev productivity. I think product managers sort of do this, where they actually are shaping the product engineering system that builds your product. And we sort of think that even by the end of this year, probably close to 90, if not 100% of the software engineers are going to be spending their time on the product engineering system that builds their product for them. And that transition is going to be very meaningful because the product engineering system has like a governance layer to it, right? Like you have to decide, how do we want things to be triaged? What is like good enough? Like how can we build automated validation? And when bugs happen, you'll jump to like, basically, how do we prevent agents from ever introducing this bug again, rather than just trying to fix the bug directly? And so it's moving up that ladder of abstraction towards like a meta system, and that we think all companies are going to basically do.
That's wild. I just got back. I think the stream's been holding it down. As they said, like everyone's really excited about tokens right now. Yeah. So, and I think other people are also wondering about people on live stream. So on the live stream, you guys will also be taken care of. So you can sign up for the LUMA link. And so signing up for the LUMA link will get you can select live stream if you're not able to be here in San Francisco. And you're also going to get granted tokens for the 200 million tokens. So make sure you check that LUMA link for those who are wondering, because we want to not only be with builders here in person, I'm going to be walking around. I'll have my IRL set up. I have my brother John here. You've been seeing him in those other streams, and we're gonna talk to people, and we're gonna have the couch too. Gonna be lounging, so this will be like the engineers kind of hot seat type of thing, and you could bring your problems and talk to us live, which would be really, really cool. So that'll be taking place next week. So stay tuned in. I know that a lot of people are coming into town for GTC and the Game Developer Conference as well, and we want to see you build with missions and stuff like that. And I think I was just checking up on my app here and trying to see what's going on. What I've done is I actually have it remoted into my other thing. I was just curious for you guys, like, is there going to be any other instance that we can run this on the cloud, or like what's your guys' thinking for the missions here?
Yeah, cloud support is coming soon. We're actually doing a big revamp of Droid's computers and like what you have access to. Right now, we have in the product a cloud sandbox environment that is ephemeral, so it sort of disappears, and like every time you start up a Droid, it's sort of like a fresh sandbox. That was sort of the model that I think a lot of people thought would be, including us, would be successful. But what I think Claudebot and a couple of these other things showed us is that giving Droid a persistent home in the cloud is actually a lot more advantageous. And so we're going to be shipping like Droid's computers, which basically gives you it's more of like a VPS model than it is like an ephemeral compute. Mm-hmm. So you spin up Droid's computer and like it's persistent. So when you go to sleep, when you wake up, if Droid wants to store files, if it wants to sort of build its own little home in the cloud, it can, and you have access to it, and you can even SSH in. You can open VS Code in it. It's got a lot of cool stuff.
We just found out about a new feature.
Yeah, that's the product marketing team is gonna kill me for spoiling it, but I think that it's exciting.
That's crazy. Yeah, because we were taking a look basically at the app that I was building here, and it's just a kind of quick overview for those if you haven't played around with it. We're basically just looking at the full-on mission control, and right now it's basically implementing some features. And so I'm implementing literally an app from scratch. It's for the Canoe Club, and it's got weather stuff. So it's checking the weather. So if you're going to sign up, the whole goal of it is that paddlers, when they're showing up at the beach, they want to know if they have enough people to show up with, like on a Tuesday or a Thursday or something. And a lot of people can't make it because of different obligations. So it's just easier. All of this stuff goes back and forth over email and text. And in Hawaii, it's just kind of loosey-goosey. But sometimes it's just easier to go to the app and say, okay, what's going on? What's the latest? Can I sub in and out? And get something in real time. So I thought this would be a really cool thing. And we have like a ton of features that are shipping here. And so it's been really fun to kind of kick this off here, because there's like a lot going on. And so, I mean, I was trying to see if I can kind of get this going through. So here are the features that it has shipped so far. And this has been working for, I ran out of tokens, so I had to pause it, but it's 247 hours. And our output is 88K tokens and the cache thing here. So what does this mean as far as like cached? How are we thinking about in terms of like tokens? What does that mean? Like, is it just, it's just read 21 million tokens as far as different files, but not necessarily charge me for them for the output, or how are you guys kind of viewing that? Yeah. Give me a second. Yeah. Go ahead. Yeah.
Cool. So yeah, the way that cache tokens work is that you're, from our perspective, you're charged a much lower rate for usage of cache tokens, right? So we bring that same cost saving to you as a user of Droid. And so as we charge you for token usage, we incur a very small, portion to be like associated with the cache ones, and then you're mostly paying for your output and input tokens every time that you perform inference. A few things to note here are this notification trigger, this is like your current worker session right now, right?
Yeah.
And so there's a few views that you can cycle through here. One thing that I think is important to just also call out, as there's a bunch of people who are going to be like trying out missions right now, right? Is what are some like potential like good and bad use cases for missions? Like what should you kind of get started with? A good one is, I think, like anything like web app development, TUI development, typically any sort of like application that you want to sort of verify, but verification steps are initiated by the user, right? So that would involve like, I need to click on this button right now, or I need to press this key, right?
Yeah.
An example of an application that would be like bad to build with a mission would be something where you have to be like very reactive, where there's like maybe like not great time spans for that sort of validation to occur. So for example, building like a real-time game, right? Where like the validator doesn't have enough time to perform inference and then also take the correct action. Like that.
Yeah. Like how to think about what to test. Yeah. Because basically what I've done here is like in my mission control, I've basically started to kind of dig down a little bit further here. And, basically showing you what's currently in progress for this specific feature that we're working on. So if I hit spacebar here, it's going to expand the preconditions, the expected behavior, and then these are the verification steps. So it's going to assign a member to a session. It's going to remove a member from the session. Mind you, I did not write any of these tests myself at all. I just kind of gave it the spec. I was like, this is what I kind of wanted, when a user gets a notification, and it sort of inferred everything and wrote that for me. Cancel a session. And I don't know about you guys, but like I used to do a lot of testing for my code, and it's a long process to set that up, to think about all the use cases. And in some companies, the engineers who do the testing are actually like, that's their full-time job. Like that's all they think about. They don't think about the code structure and everything, because in some companies, they actually believe it kind of pollutes the thinking there, that they actually want someone who's just a super system user that can set up the environment, but then test it as if they're like a user and have no clue of how the actual code is composed, because they test more of the runtime.
I think, to interrupt, like, it's pretty interesting you say that, because I'd say like the separation. So individual workers do like test their own code, right? Like, so I mean, they validate, so they'll like use it, like use the user surface. But ultimately, like, they are not the ones checking off like this validation checklist, right? That we designed during planning. Ultimately, we have like separate validator workers. So it's kind of a similar thing where like you don't want to like you don't want the validator's context to be polluted at all by any knowledge or attachment to the implementation, right? I just think it's pretty interesting that you have something pretty similar.
It's very true in real companies. I used to work for this fruit company, and I'm not saying that's exactly what they do. I'm just saying that's what I've seen in different places, if you know what I mean. But yeah, I think there is a lot of value in that, as because these people get very creative at finding these problems that that are only reproducible with either their own data sets too, or whatever they're doing and how they configure the machine to use the software. And I think that's also where the different personalities really come into play too. And you guys talked a little bit earlier about the model personalities. You know, Opus 4.6 has a new personality, and now GPT 5.4 is coming in the mix, and people are already seeing different things. And you know, I'm it's going to be really curious. So when these new models get announced by you guys and you put them in, they can then change them now in the harness and stuff. Okay,
Yeah.
cool.
Yeah.
So like if I go, let's see, I can just kind of go back to my app here. Let me see if I can kind of go in here now. So what I could do is like, this is my current worker session. If I hit enter and I get into my actual mission control, like just to like zoom down all the way in to see what's going on. And then this looks like it's telling us there's 85 different tasks. If I scroll with my actual trackpad, I can see everything that's been going on for this exact like worker session. And so this tells me that it's using the model Opus 4.6 high. And this is the feature that it's working on. And this is kind of where we're at right now. And then for the feature to actually exit, this is actually its own criteria that it generated at the time of it kind of setting up the mission. Is that what it is here? Is that what I'm seeing?
You talking about end feature run?
Yeah, the end feature run. Yeah, success.
Yeah, end feature run's kind of just the tool that's called at the end of each worker session to like indicate that it's done. And
okay.
yeah, it contains some like parameters. Like one of them's like a handoff. It's kind of like a summary of what it did.
Oh, okay.
Like
That's the
structure of which is defined like by the orchestrator.
Yeah, I think if you hit H, you should be able to see.
Okay. Yeah, this is says like I integrated all this stuff with the 5 tests, right, or whatever, and verified the admin triggers. And so this is cool. Like I didn't have to do this. The agent's doing this, and then what was left undone, and then any discovered items, and that's for like the handoff. And so this will hand this back off to the orchestrator, and then it would say, okay, cool. Let me go ahead and look and see what's going on with the rest of my work that I need to do, and see what other stuff I need to do. And this is the serial process, right? This is not parallelized. This is just like one by one by one. And this is kind of why some of them can take so long. It's not that it's burning tokens, but it's either writing the test, doing the verifications, or spending a lot of time wherever it needs to be in the app and stuff like that, right?
Yep. And you can use the M key here to switch into a different model that and then change models as you might.
Now I could change the new or I probably have to exit, right, to get the new model.
No, 5.4 is up there.
Okay, cool. Oh yeah, cool. Awesome. Let's go. Let's get. Oh, so this was interesting because I saw the paper. So they said that 5.4 medium was, I think, equivalent in terms of speed and accuracy to then 5.3 Codex high. I was trying to figure out what that was.
Yeah, that they well, oftentimes those papers say a lot of things
Yeah.
that end up being like sort of like questionable in practice. I think generally medium and high are pretty difficult to tell the difference between. But I would say that from our early tests, we did find that extra high by default was actually like works quite well.
Yeah.
But we haven't yet actually run enough rigorous. I mean, this is a good time to talk about like evaluation.
Yeah.
And like how we evaluate this, but we haven't run enough rigorous evaluation on GPT 5.4 yet.
Okay, cool.
Yeah.
So in the middle of this run, now when it is doing a validator task, it's going to switch right into that during my mission here.
Yep.
Dang, that's cool. And
Yeah.
so then I can go back with escape, and then I'm back at our like mission control thing. And in the mission control, just tells us what the active feature is, other features that we've worked on. And then if I scroll with my mouse, there's a progress log of 1 of 8. And then I can keep scrolling down. So I can see what's been happening. Like, 5 minutes ago, this is what's happened, what specific things here. And then this shows us the duration for the current task for 5 minutes. We've been kind of doing this type of thing down here. And to go back to the orchestrator, Control G will take us back over. Whoops. Yeah, cool. So this is basically what you would normally see if you're just running normal prompts, right? If you're scrolling back up, this is kind of what happened and how I kicked off my orchestrator. And this is what people are kind of being able to see here. And of course, my window is kind of running a little bit laggy, but we're kind of taking a peek about this is, when we're starting my mission run here. And so this, in order to like punch right in. So tell me more about this like terminal UI and how you guys like, it's always such a cool design. And you guys, I know there's another design that just came out after this because this was already running on my machine, but like branding and how did you guys kind of fall into like this cool vibe of what you guys do with your terminal UI. Because also, did you build this first in the terminal UI, or how did you kind of come about this when you first kind of designed this system? Yeah.
Yeah. So the initial version wasn't in the TUI actually. We built it separately, and then once basically like missions got into a state where it could consistently like work, we just used it to basically like a single mission to build the entire like interface that you see in this TUI.
Wow.
And it just like it works well enough such that you can like truly like, it's truly just like a vibe coded it, you know? Because you don't actually, you can just trust, like, especially for like building an interface like this, it's just going to be correct. So you can really focus on like designing it, and yeah, so it makes it a lot more fun.
So you started to use missions to build the missions UI.
Yeah, at a certain point, it's like, okay, let's make a good UX for this. Just run a mission to do it.
That's an interesting point. So do you think that a lot of open source projects will now start to evolve pretty fast with this type of stuff? Because now there's a really good baseline for certain things. And I feel now they just can add specs and stuff features earlier. Because I had someone who reached out to me. They have like a team. They have researchers. They have other project managers. All these people want to ship features, but their bottleneck is testing. And the engineers who spend so much time on the code, how comfortable, like if you have a researcher that comes in and they don't know how to code, would you let them start tinkering around in your guys' code base? Like, what is your guys' thoughts with that?
Oh. I mean, our third highest user by token volume inside of Factory is one of our salespeople. Like we have, I mean, our belief is that software is just I feel like for so long, software was like this thing that was gate kept by like the like priestly class. It's like, if you don't happen to know how to arrange the arcane incantations into the right way, you're just not allowed to participate in building software. And I think that is just totally done. Like we literally, in fact, have this internal evaluation that we're going to be responsibly disclosing soon. Oh, there's the lights.
Yeah, someone's got to move. John, go move around.
Dude, that's they're listening in. They don't want me to talk about this.
They don't
eval. And basically, like what this eval, we call it SaaS bench.
SaaS bench. Okay.
Yeah, so it's a collection of 50 of the most popular SaaS products.
Whoa.
It is a like 0 to 1 replication of the 50 most popular SaaS products, like from scratch.
Whoa.
Like some of them have as many as like 160 features. And basically what we're doing with Mission is like testing missions with it. And like, hey, like if we just say, please create Zoom from scratch, how far do you go? And the answer is you go all the way, and you actually can just do this sort of stuff. Like Slack was one of the first ones that we did. And the initial version had like maybe like 40%, 30% of the features of Slack. The spec that we're testing has like almost all of the features of Slack. And I think that what we're trying to figure out is basically like, what are when you look at it, you're sort of like, yeah, clearly this is not Slack. Like there's so many aspects of it that you're like, like actually the like slash commands don't come pre-populated with clever ways to go. But like like if you showed this to somebody 2 years ago, it's objectively alien technology. You can just point at any piece of software and say, please replicate, and you will get maybe 10% of the way there. But if it's simple enough, you'll just get 100% of the way there. And so to us, it feels like sort of if you sort of think of the underlying software as like the thing that is special, I think that era is about to be over. And instead, it is how that software evolves over time that is going to define what is like Slack. The reason that I would highly recommend against replacing Slack with a mission created version of Slack is that Slack is going to start shipping features much faster, right? And so like they're going to start evolving their product. They're going to be reactive. And so you have to think, the calculus is like, what is the maintenance burden of evolving this software as quickly as a group of people who are dedicated to just working on that software can evolve it. But if your software is like basically like one and done, like if it's just sort of like it has a clear purpose and that is all it needs to do, then I do think that you can basically just fully replicate that.
So would you also say I think there's a group of younger people and other people who are being like displaced that feel bad because they're like, well, I had this important role at this company and no longer I'm there. To me, I feel like this is the time window. It's kind of small to say, well, they're still dealing with their bloat and figuring out how to get rid of people and whatever. I'm going to take this one feature that I use all the time or that I know is really popular. People are asking for it. I'm just going to go to the market and make it overnight and see how many people sign up. Right?
Yeah.
Like throw a mission at it, spend $100, get 10 people to sign up for $10. Like it's already paid for itself, and then keep iterating fast and like start testing your idea, and you can start to grow in verticals that these companies maybe haven't put enough energy on, and you're just locked in on the weekend. Like, right? Like
We have strong.
yeah,
The mic over.
yeah, go ahead.
Yeah, but we have pretty strong conviction that like the amount of people building software will continue to increase, right? The amount of software that we as a collective like species are creating is just going to exponentially grow, right? And that's because every single time you go to market with something, there's an additional need, right? There is something else that someone else needs to build. And so, the situation you described is entirely accurate, right? There's going to be all of these like problems that the 4,000 engineers laid off of Block, right?
Yeah.
That like some of them are like my friends, right? Are going to go in and start solving, and they're going to have like a huge amount of success doing so. So I think there's a lot of like doom in this era, right? Because it seems so visceral. Yeah. But there's also a lot of opportunity, I think.
Like never before in the history of like humanity have you been effectively like maybe like 600 keystrokes and an idea away from changing the entire world. Like you can publish on the internet immediately, right? Like you can post on Twitter immediately. You were 600 keystrokes waiting maybe 24 to 48 hours for a mission to execute and then hitting publish on Vercel away from actually changing the way that somebody lives their life. And that applies for everything, right? Like there's people who have all these problems that are unique to the geography they're in, to the culture they're in, to the groups or clubs or social environments that they're in. And like you can now just solve all of those problems like just by having the idea. Wow. And so I feel like in that world, why would people stop? Like, why would people do that less? That doesn't really like. It seems to like quite obvious that we will just have way more people doing this. It's just more accessible.
Wow. What do you say to the people who are extremely concerned about like the current state? Maybe they've been interviewing other, computer science people and they say, what model are you using? Or, do you rely on these things and like so forth? And how are you guys so bullish and why are these people so bearish? And like, what is your guys' response to that so far? Because I mean, I see it shipping. I'm interacting with a lot of people around me. Sometimes I feel like I'm in a bubble, but I don't know. What have you met someone who's completely like tried this stuff and like I don't know. I don't get any good output. I've been working on this for 12 years. Is just the way they're thinking, or maybe the expectations of the models, or like what's the shift that's happening? That like what do you see that they're not?
When you say, do you mean like bearish on like AI technology? Or
yeah, they're just like, well, it's like I don't like the outputs. It's not like a normal, like it's not the way that I would write code as a human or something like that. I've worked on this, Objective-C runtime and like I did my thing or whatever, whatever it is that they're working on. They're very proud of what they do. And, maybe they write less lines of code. Maybe they say like, less lines of code is better than, AI's like thousands of lines of code.
Got an answer to this?
Yeah. My bad.
No, you're good. I really love writing code manually, but I think just like that's the nature of like our craft is changing. And yeah, I mean, it's just on people to acknowledge that and like kind of learn new things, right? And I think that's part of what made software engineering so, just like fun for me was this opportunity to learn at every stage of the way. Like I was learning new technologies, I was learning new ways that I could optimize my workflow. I was writing like Vim macros so that like I could like, type faster essentially. and so now it's just like a different type of learning, right? Can you maybe write the skills and code the workflows that previously you were doing manually into skills and maybe build a collection of them such that you can orchestrate portions of your dev workflow that you didn't enjoy, right? I think, and there totally may be people who enjoy coding so much that they want to continue doing the coding portion manually. And maybe that's like totally valid, right? But then they can encode portions of the work that they don't enjoy and delegate that off to AI.
That's a good point. Like I also noticed too in debugging, like that's a skill that I learned just working on the operating system. And then you learn, oh yeah, that's just how an environment works, or that's just the quirkiness of things. Do you feel like we'll lose that sense too, or those intuitions that we've built up over time making software? I mean, what do you guys think about that?
I think that probably like the way that this manifests is that there's an immediate term sort of sense that skill is going away because you have a bunch of people who are net new coming into the field who are just like, now I can just say like, please build me an app. And then you're like, oh, what framework did you use? And they're like, what do you mean? And you're like, well, Next.js or Vite. And they're like, I'm pretty sure it's
Droid?
TypeScript.
Yeah, like,
yeah. And like, I think
Opus.
that's going to happen and that's fine. Like, I feel like the longer term thing here though, is that, and especially when we're talking to enterprises, where I think that like we've been speaking a lot in the framing of sort of people who are building like applications and who are sort of like, you know, front ends. And I think though that if you've spent the last like 15 years of your life working on a COBOL mainframe, you're living such a different world from the rest of the people who are working on like, you know, Python systems or whatever. And for them, I think that first of all, a lot of them are like, please take this off. Like, I would be happy to never have to deal with this again. But then there's a lot of people who are sort of like, oh, the craft of this, like, who's going to know how to do this? Personally, and I'm curious what your take is, like, I've found that I know infinitely more about software from watching Droid work than if I just was doing this myself. Like, I think it's like not even close. Like, I see Droid do things. I know Bash so much better. I know how my computer works so much better. I know how Git works so much better because you're like watching the system sort of work. And even with missions, like you start to get a sense of how systems should be architected in a way that I don't think a junior engineer would ever get exposed to. You're literally seeing a system think through systems in a more principled way than almost any human you'd ever talk to. So it seems to me like it's quite compelling. I don't know. What do you think?
I guess like that makes sense. You know what you said? I think for me though, like it's just that like I'd say when I'm using like missions or I'm using Droid, I personally don't like tend to look super closely at like, you know, what commands it's running and stuff like that. I guess it's just like a certain, you know, different types of people, right? I think I'm more interested in like how I can get this entity, this agent to do stuff. And then you kind of get an intuition for like, you know, the realm in which it can operate, you know, well. And it's kind of you're like, you can kind of live on like a different level of abstraction kind of on top of the LLM.
Talk about the entity part, because that's something we were talking about last night, in that I was explaining to him behaviors as if like I'm talking to a person or personality. And I don't think that way when I'm thinking about code. When I think about code, I think about concepts and like almost like I'm picking up materials, right? Like this material does this, has these properties. What can I expand on it? What can I scaffold? When I'm thinking about talking to an LLM, it does feel like an entity, right? It's like, okay, can I just point it in that direction and just kind of give it some roadmaps and say, here's a thing, like you're going to figure it out. I'm going to let you do this thing. I feel like that's a different way of thinking than code writing. And you talked about entity. I want you to kind of also expand on that. I'm like, what does that mean to you, I guess? Yeah.
Mm.
One thing that I think I can speak to here is, and I'm probably gonna hand it back over to you, Theo, is just like I think Theo, through prompting like extensively, has built sort of like an intuition of like how the models like have their own personalities and are good at specific tasks, right? And so I saw this in like your work in compaction originally. Like we were talking about what is the right model to do compaction. Eventually, model labs kind of all caught up to the problem, and then every model sort of became good at it. But as you're working on these like frontier type of problems, you have to pick and choose the right model for the task, right? And I think you've done that really, really well in missions. Like a lot of our initial builds used exclusively Codex. Then, Opus 4.6 launched. We started experimenting. We've, ran a bunch of missions on like EC2 instances, try to see like, what are the trends that we're seeing across different models, and then kind of learn from that. So what do you think are like some of like the personality traits that you've observed in like the models that you've been interacting with recently?
Yeah, I mean, there is like kind of the aspect of like models do have their own like tendencies. Like they absolutely do, right? Anyone who uses LLMs a lot, like you notice like, like on one hand, they're like random, like they're non-deterministic. But I guess it's just like on a high level, like their behaviors are actually pretty predictable. And like another thing I think is like the fact that they're like I view this as like an entity or like a creature or something, right? The fact that they're like that means they're also like they can handle more kind of cases. Like they can kind of self-heal, I guess. That's a big part of why I guess missions work and why kind of I can just operate on like the level of like the prompting level and still get good outcomes. It's just like they are smart enough and like flexible enough that they can adapt to like different like variants of like a certain scenario or like kind of different variations of like, something they have to heal from.
And so especially having validators is kind of one of the healing forms.
Yeah,
right?
I guess like one example of like
Yeah.
the fact like validators, like their trajectories are not going to be deterministic, right? Like it is an agent kind of going through and like let's say like manually clicking through your app if you're building like a full stack app. But what you can rely on, especially with like let's say if you're using 5.3 Codex, is that it's going to validate it properly. I kind of view like missions like because missions is like a system built. It's a system, right? There's like a lot of structure. There's like code structure. There's like enforced kind of handoffs and but also it's like a system around these creatures kind of.
Yeah.
And it just like there's power in having like these creatures be like flexible and non-deterministic, I guess. I guess I can also think of like human organizations, right? Like human teams. Humans are also obviously non-deterministic, but if you like kind of you have a team that like coordinates properly and knows what they're doing, they can like have very, very high success rate, right? They can be very, very reliable.
That's right.
Yeah.
Yeah, because when these people, when they're not in an organization, they're just kind of random. Like you and me doing whatever we're doing.
Yeah.
But when they have a mission, no, when they have like a goal and the company's just very focused, the output is they all have their own lives. Everyone's doing whatever, but they still have to come back.
Yeah. Yeah. I guess like, yeah, like it's pretty fascinating to me in general that like huge like organizations of people, like people will generally fall in line. Like you can get pretty predictable outcomes and you can kind of control like all these people. I think similarly, like it's I think I need to think a little more about this to like sit on it.
Yeah, it's okay.
But
it's really enlightening as far as the topic. Yeah.
Yeah. Well, one like, comparable point there is just like how we have thought through the different models that we're choosing intentionally, right? If the validator, or when we think about validation, it has to be quite rigid to the idea of that was initially proposed as what needs to be validated, right? Yeah. And so you can spend a lot of time thinking about it, but you want to be very focused, right? And we've typically observed that Codex models or OpenAI like ChatGPT models are really, really good in that sort of setting, right? They can think at large about the problem and then act within that bounded scope well, but they are slower, right?
Now faster
and
with GPT
now a little bit faster. We'll see,
5.4,
how it really ends up turning out with missions and stuff. But on the flip side, when you've got something that maybe benefits from some creativity, right? Just like how you would have potentially a more creative human, you have a more creative model that perhaps is better at doing the implementation work. So something like Opus 4.6, we found to be really, really good at that sort of like implementation logic, right?
Yeah, like design and everything.
Yeah.
Wow.
I think that the thing that for folks who are interested in this stuff, I think that like the whole field of cybernetics generally sort of talks about like feedback loops and stable systems and also and like input output signals. And I think that the idea that sort of there's actually such a rich body of work of where people are trying to investigate like what is a like high quality stable system that has an equilibrium. And I think that we thought about feedback loops a lot when we were trying to build this system. What we wanted to do is we wanted to say, like, what are the feedback loops and signals that enable an agent to, even when it veers off course, return back to a stable point? And that's sort of, I mean, a big part of what agent readiness is also meant to do, or like all the things that fall under that, is provide signals such that the feedback loop of, you know, agent works, makes system better, thus it can do better work in the system. Thus, it can make the system better. Like that enables you to inject energy into the system, or like more agents, more time, more tokens, more. And it, instead of going totally chaotic, it's at a stable point. So it actually grows. And I think that we're trying to figure out better ways to increase the clarity on what those signals are, what those feedback loops are, how to inject more and more energy into these like effectively like cybernetic systems. And there's probably like a really clever way where you could line all this up with a great algorithm and like put it on a paper and archive. But I think that one of the things that I love about us at Factory is that we spend the vast majority of our time, the moment we uncover something, ship it, get it to people, let people use it, and take advantage of like sort of all of this. Avoid spending too long in theory land and just execute on building something that people can love and use. And then, you know, the outcomes of that are much clearer.
So for those who are wondering, this missions idea started 2 months ago and 3 months ago. Yeah. I guess we're in March now. And you pretty much worked nonstop once you started to uncover like the things of what was coming to be. And now it's coming out there, and other people have also like noticing similar patterns here. But we touched about this a little bit earlier. Like you have like this massive system where your task is out there. It's going to, you know, plan, execute, validate, learn some skills, and then kind of do this circular types of things. And you're adding all these different guardrails. And I feel like there's this compounding effect with your guys' company, which is really interesting, is that all the work that you've done prior is kind of leading up to this moment and is like continuing to go further, right? Like you have this harness that's already really good and you just keep compounding it. And have you changed much of that code originally that you wrote for the harness, like for compaction or anything like that? Or like, are you rewriting and ripping everything back out? Or like, what's the thinking here? Or is it already good and you just leave it alone? Or like, you know, I'm just curious from a software design perspective, you know?
This guy changes the like he's 100% code churner. Like the code I feel like does not resemble anything like what it looked like even 4 weeks ago.
Wow.
Yeah.
Wow.
I think, I mean, we're always looking to like optimize that portion of the code. Let it be the actual like harness that we're working on, or it could be like the performance or the memory usage. Like today, I've just ran a mission to like change all of our code so that, you know, we can like optimize our memory. And that basically led to 110 memory or 110 megabyte memory drop in just Droid itself, right? So that will sort of benefit us moving forward. But I think the idea here is just like, there's portions of the code that remain relatively like static, right? A lot of our work in like prompting the model remains static, right? Because unless we learn something new from like our evals and stuff. But a lot of like the way that we think about the UX, which is deeply ingrained into the actual harness itself also changes drastically, right? We now have decoupled this idea of like the mode that you're in, which is like the normal mode or spec mode, with the autonomy level that you're operating at, right? And so that was like a change that we made, I think, a few weeks ago that naturally required some changes to like the harness itself too.
Yeah, I'd say like anything that like LLMs are good at, is a subject to change within our code base. But stuff like prompting, I'd say, particularly like the more like between the lines aspects of prompting is something that LLMs are still not great at. So like we tend not to let LLMs like write our prompts.
Oh,
So they'll change less often because the human has to change them, right?
interesting. It's funny because I've heard a couple people say this, and is it because you keep them more succinct than LLM would write them for the prompts that you guys use to steer these systems, or?
I feel that LLMs just don't have a really great like intuition or like implicit understanding of like how like little changes like ordering of like the lines in your prompt or like the exact wording or framing you use and how that can affect different models. I just think it's something that they have not practiced during like their training.
Oh, I see.
But like code, like writing code, it's
Yeah.
like I don't have to look at the code. But like for prompting, I'm not gonna like if I get an LM to like write part of a prompt, I'm gonna scrutinize it like really closely.
So, I mean, do you guys have any advice for people who are, trying to like, I think that's a really good note, right? Like prompting, like spend more time like thinking about what you're going to say to the model or what outcomes you want. Like, I feel like that's kind of how my thinking is shifted. It's like, okay, what do I really, really want from the model? What don't I want? I guess, is also just important. And then having that little exercise back and forth. So, yeah, for those who are interested in kicking off missions, if you want to check out the LUMA link below, that's where you can go ahead and sign up. So we're going to have an event here next week at Factory AI. So Factory is currently sponsoring the stream, and they're sponsoring next week's in-person event. And so you can show up, and you can also participate on the live stream as well. So you can select live stream, or you can also select in person. And we're just going to go through and just grant you 200 million tokens. So you can have 200 million tokens to go ahead and start kicking off some of these missions and start to play with it yourself. You can use the latest GPT 5.4 model. You can use an open source model that you want. You can even run stuff locally if you want as well. But for the most part, you probably want like the orchestrator or the smart one to be a really frontier model, and then have like a validator model to be, another pretty good model as well. And start to kind of play around with it, pop it into your code base and do some cool stuff. And so you'll get to play around with things. And in a couple of days or so, probably like by Tuesday, we're going to take a look at that big email list, and they're going to be approving people because I think there's only like 100 something spots that we can have for folks to come here in San Francisco. And if you're not in San Francisco, that's okay. You can still get some tokens. We're going to do it live, broadcast live. And so, bring your problems and stuff, and we'll be able to answer them live. I'll be here with my setup and the crew, and we're going to be answering some questions. And, if you've been playing around with it, you run into any bugs, just let us know. I think it's going to be super helpful to, catch up with y'all and cook you guys up, because this is the type of thing that, we've been chatting a lot about, and, it's pretty exciting to see this kind of like coming out to the wild. And so no matter what plan, you can actually start playing with it right now. It doesn't require a pro plan. You can actually start, with the basic plan to get going on with your missions. And so I think this is probably a good time to kind of start, wrapping some things up. I really appreciate you guys' time to sit down with us. And, you guys have worked so hard to bring this out to the market. And I think there's like a huge shift that's actually starting to happen. And I think it's really exciting to get to play with it. And I like to learn by doing. And I think my audience feels the same way as well. So yeah, thank you guys.
Thanks for having us.
Thank you.
Yeah. Any last words you guys want to say, or anything that you want to hand off to folks, we're wanting to use this stuff, or like, anything that you want to, say to the audience?
You use Codex or use GPT model as validator.
That's facts.
What I would say is that this is like still like super early, and so we'd love your feedback. Like if you want guaranteed extra tokens, use missions, and then DM me on Twitter and explain exactly what went right and what went wrong. That's another great way to get tokens from us. Is we love feedback, so please do let us know how it goes. I don't know anything.
You good?
No, that's all.
Yeah. So like check out the link below. It's going to be in the description for you guys to go sign up for the LUMA link. You're going to either sign up for the live stream or sign up for the in-person. If you're in person here in San Francisco, go ahead and sign up. We're gonna get some food going. We've got a whole bunch of stuff going with like the tokens. We'll also have some prizes for you to win as well, which would be really, really cool. And the live stream audience, you'll also be able to get some of that token love as well. And if you're burning through crazy tokens, let us know. And obviously the feedback is going to be super duper helpful. So yeah, that's Factory AI. We talked a lot about like kind of missions and kind of, these people like are so serious about just agentic coding. And I really think that you guys have been on the frontier for a while. And I mean, you guys are so locked in. It's not like it's like I'm just honored to be here to just be able to talk to you guys and excited to come back, bring people in as well and kind of start to play with this stuff. And, thank you so much for sponsoring the stream and getting some people out here to play with these tokens. And, this next thing, you're 600 lines away, 600 words away from your next possible breakthrough. And I think this is a really great platform to start playing with, start experimenting with. And if you're already on it, if you're an existing user, you can still get some of that stuff. So go ahead and sign up. Thank you so much to everyone on the live stream. Make sure you stay subscribed and be tuned in, and we'll see you guys soon. Peace out, y'all.